Hello everyone, my name is Vikram and I am the operations manager and your host for today's web. Today's webinar is very interesting. That is, the topic of today's webinar is scaling up battery production with smart automation. We are delighted to have our partners and experts from C4V and Rockwell Automation joining this webinar. I would like to welcome our experts, Mr. Olin, who is the Chief Business Officer at C4V, and Mr. Shailesh Upreti, who is the CEO and co-founder at C4V, and Mr. Christian Leitner, who is the business leader, future mobility at Rockwell Automation. Thank you very much, everyone, for joining this webinar. Uh, Now I request Mr. Shailesh to introduce about C4V in brief. I can share.
Yeah, thanks, Vikram. Thanks for inviting me and Cliff to this webinar and very interesting topic today. C4V started back in 2012 with a goal to make energy storage affordable and available. We have some innovations that eliminate components that have been very notorious along the supply chain, whether it's a cost and availability. Plus, we have a very unique business model. And as you can see on the screen, the best way to understand is through a triangle where C4V sits at the center of the triangle. And instead of having a linear value chain, we have tried to give it a twist, a little bit of twist, where it forms a triangle so that the value chain partners could communicate and we can solve problem, not just a product problem that gets launched and then having that product available, typically in our case, lithium ion battery cell, and a very robust supply chain to support that manufacturing. So that's how C4V sits at the center of this unique value chain, and that is also a business model where we are going after emerging markets to build gigafactories. The goal is to have about 100 gigawatt hour by 2030. So that's a brief introduction. I hope that gives you a little bit more visibility into what we do. And we are with obviously four core philosophy, whether it's innovation, sustainability, electrification, and then we look into molecules to machine where automation also become very, very important. And we're very excited to have this webinar today and nice to meet you, Christian and Vikram.
Thank you, Shailesh, for that introduction. Now I request Christian to briefly introduce to Rockwell Automation.
Sure. Yeah, it's of course also a pleasure for me to be here. Let me give you a high-level overview of our company, Rockwell Automation. So we are a global leading company that is solely focused on industrial automation and information solutions. So that's really all we do. We are headquartered in the US, in Milwaukee, Wisconsin, and are also, of course, active in more than 100 countries worldwide. Some 29,000 employees generated a revenue of 9.1 billion US dollar sales in 2023. If we look a little bit on how this revenue is distributed, you will notice that almost a third comes from software and the rest is from automation hardware and services. So we are, I think, a true OT IT company today. Basically, we serve all industries with our solution services and products, no matter whether it's a discrete process or hybrid application. And the battery industry specifically is one of our core industries. So that means we do have a global battery team in place with battery experts, of course, and what is even more important, solutions specifically developed for the battery industry. Thank you.
Thank you, Christian, for the introduction to Rockwell Automation. So let's begin with the webinar questions. First question to Mr. Olin. C4V has an experience of setting up R&D pilot line as well as mass production lines on a giga scale. Can you explain what happens at each phase and what's the role of each phase?
Yeah, thanks, Vikram. Shailesh kind of laid out our business model. So we are fortunate enough to be involved in R&D line, a pilot line, as well as mass production lines and setting those up for folks. Our R&D line, we were fortunate to be affiliated with Binghamton University in New York State, who's been a great partner for us since our inception. and they have provided some significant infrastructure for our R&D line. In fact, all of it has been provided by New York State. Now, to be clear, we pay to be there, but versus the huge CapEx expense that we would have had to make in order to have access to a line like this, it's pretty efficient use of our funding and so on, being an early stage startup company. So we are fortunate enough to have access to that. On our R&D line, really we're constantly iterating and checking our existing chemistry as well as looking at new chemistries or new technology out there that allows us to do very small runs, obviously, because an R&D line, they differentiate by capacity. R&D line isn't meant to be a large volume production unit. So we're very fortunate to be able to use that to iterate our existing tech as well as evaluate new technology right in-house, within steps of our main office and have access to that. A pilot line that we have created over at the Phoenix campus, which is the former IBM worldwide headquarters, is larger. It's meant for different things. So once they move from the R&D line to the pilot line, the purpose changes a little bit in that we're looking to create samples for our end users and partners, as well as small production runs just to simulate the production at a larger mass scale. And really, that I think, and the way that I look at it, is the innovation happens at the R&D line and the pilot line. When we go to mass production, it's really a different ballgame. As Dr. Urpeti mentioned, our goal is to have 100 gigawatt hours worth of capacity by 2030 in various locations around the world, and we're in various stages of discussions with partners around the world right now. But it's really a global strategy, and the scale is mass, obviously, or commercial, if you want to call it. So C4V, being a development company, moves things along the R&D to the pilot line to mass scale. If it can't make it to mass scale, we really don't have a lot of use for it. So we go back to the drawing board until we do get something to be mass scale. But in that particular case, when we're at mass scale, repeatability becomes the issue. Can we can our partners create a product that is consistent in its performance and its capacity, et cetera, et cetera? So we really see the three different phases of production and the nuances that make them all unique and certainly worthwhile to achieve. And then finally, I'll just say, with relation to our talk today, automation changes across those three. So an R&D line, not a lot of automation in that. We'd rather be at high touch because we want to know exactly what's going on and so on. A pilot line, more automation, but still maybe we'll call it semi-automated. But in our plan, our idea is to have these mass production facilities be as automated as possible, 100%. We're still a large employer in these particular cases and in the local economies that they exist in, but a higher degree of automation is definitely desired when we get to mass production.
Thank you, Mr. Olin, for explaining in detail about what happens in each phase. Mr. Christian, does automation really plays a role in R&D phase or in pilot scale production?
Yeah, sure. So, yeah, I think I can just agree with what Cliff just said before. So I have a similar experience, of course. It's no surprise. I think automation expertise in general always plays a certain role in every modern manufacturing environment. That is clear, right? But specifically, in my experience, if we look at research and development, if we look at a smaller prototype line, then maybe automation plays a smaller role, at least at the beginning, right? So because this is mainly manual processes in a kind of laboratory type of environment. But as soon, of course, as Cliff mentioned, if you move up to a proof of concept, to a smaller, to a larger pilot line, where you want to start to test and validate whether your product and your developed processes still work with larger quantities involved, I think this is where you can start, benefiting a little bit more from automation and automation expertise. And of course, in particular, if you move up to, I would say, starting from megawatt scale, this is where things get really interesting, where we are also typically engaged at Rockwell with challenges such as how do I master quality, how do I implement some traceability, how do I do some basic production scheduling, how can I implement some monitoring or reporting system, or how do I even do some basic maintenance, right? So this is where things come into play. So concluding here and maybe echoing Cliff a little bit here, I would say the higher the speed, the higher the quantities, the higher the complexity, the more you can also benefit from automation and automation expertise.
Okay, thank you, Christian, for that answer. Coming to Mr. Shailesh, what are the key challenges that the battery manufacturer faces while scaling up to a gigafactory level?
Yeah, so I mean, the cell manufacturing, particularly right before the battery pack manufacturing, is quite complicated. Any unit, I keep giving example, any unit that exists under the sky, whether it's a dollars per kilowatt hour, dollars per kg, dollars per liter, dollars per square meter, dollars per, per mile, dollar per piece, that's your input for all the raw material you get in, right? So you buy foils, you buy liquid, and you buy powder, and then everything you have to kind of put together, and everything gets married in the cell, and eventually the cell, you don't the lithium ion cell, you don't sell in the market by weight or by volume. You sell it how much energy it stores. So in that all mixing happening, I think there are a lot of complications. So the chemical process is there, and as you can see, the animation I'm showing in the background here, there are three major steps, but each step then within have sub processes and starts with all the chemical side. And if the chemistry is not right, you start generating obviously waste afterward. And once the chemistry gets let's say put together, then comes the mechanical part, where you mechanically, whether it's a cylindrical cell or a pouch cell or prismatic cell, how they get cut or wound, and all the weldings and whatsoever needed. And in that, all has to be in a dry environment to avoid any moisture content. So that brings another challenge, that you can't just build a fascinating factory in kind of open environment. So you have to have a very moisture control environment, in addition to your other quality controls you have to implement. And that makes the manufacturing and automation even more important, because you can't have people working inside the dry room for long, because dryness affects the human body, and everybody has their uh, body reaction to that, and we have to then adopt, and it takes time to train people and get used to in the dry room. So automation also helps there. And then the third part comes the electrical and power, where you basically do the formation, etc., and aging, and that lasts several days, sometime all the way 2 weeks to do the aging, and before you do your final quality check. So challenge, each step bring its own challenges, from chemical to mechanical to electrical. And as Christian already mentioned, when you go from lab to pallet to then mass scale, where millions of cells need to be produced, uh, there are a lot of failure that happen, and it takes time. It's not easy. People think you will be up and running, and we have faced those challenges here in IM3NY, in New York as well. But then you overcome those challenges and move to the next step. um, and eventually, you kind of balance out. We call it total system integration, where you in principle, your chemistry and your electrical, they are all communicating to each other, and you balance out the plant, right? And eventually, hopefully, that also meets your customer specs. And so there is a journey, from that R&D to that giga scale, that you have to go step by step. And money can't buy you that whole journey. You have to spend time and go through that learning. And that's where I think various challenges start coming, if you kind of take shortcuts or bypass some steps.
Okay. Thank you, Shailesh, for sharing those challenges while going to a gigafactory level. Coming to Christian, can Rockwell Automation provide solutions to assist battery manufacturers such as C4V in overcoming the challenges of scaling up to a gigafactory level? And what specific tools or strategies do you recommend?
Yeah, well, scalability is indeed a very interesting topic, and honestly, it's not easy to answer because it depends on so many different criteria, and also where you start as a company. Are you an incumbent company with already some existing technology, or are you really starting fresh as a completely new startup? But let me maybe make an attempt by starting with the very basics here, as how we see it as an automation expert supplier. So I would say if you look at the manufacturing plant, it all starts with the manufacturing network, which is really the backbone of every single plant, right? So, and as you grow as a startup, your network will have to grow with you. And at the same time, you need to make sure that your network still remains efficient, safe, and secure. So the keyword here is really cybersecurity, right? And by the way, the network is also fundamental for digitalization. Everybody today is talking about the latest and greatest digital factory. But in order to achieve that, you need to get the basics right, and that again is the network. So everybody also, once you grow, you add more and more machines, you add more lines, the complexity increases. You want to make sure that your machines can communicate with each other, right? At very high speed in the best case, of course, also providing real-time insights so that you can also get some or make some real-time decisions. So that's, I think, the first very important point that is very often not considered or not, considered enough at the beginning, I would say. At Rockwell, by the way, we use Ethernet IP. I think everybody is familiar with Ethernet, right? And the advantage of Ethernet IP is that it really integrates everything that you need in your battery manufacturing, from from motion to safety, from the smallest sensor on your shop floor up to the IT to the ERP layer. So that's a huge advantage, I would say. If we move one level up to everything related to doing the controls and visualization, I would say the simpler the better, of course. So at Rockwell, we suggest that you only focus and use only one controls platform, and by that, you can reduce a lot of complexity. And of course, at the beginning, if you do the design and engineering, it's really advisable if you do at least some minimum standardization or create some minimum specification documentation. With doing that, it sounds simple, but it's also sometimes there is not enough attention on that area, and you can really avoid a lot of costly oversights and reduce a lot of complexity with proper documentation. So at Rockwell, again, same as with the network, we use just one single controller that basically covers everything that you need in your battery production. So that's another huge advantage in terms of complexity reduction. And then the last point, maybe if you move up, you somehow also need to manage all the operations, right, with some kind of manufacturing execution software, operations management software. And that, of course, needs to be scalable as well. That also needs to be able to grow with you, right, once you add more and more machines and lines. So at the beginning, a startup might only want to focus on basic things. How do I do my quality, as I said before? How I do the traceability and maybe some production scheduling, and that's it, for the first line. But then eventually, you will have different requirements once you scale, and then all of a sudden you will require new functions. And if your software is built modular, you can just add more apps on top of it for more functionalities. So that's another advice I think we can give. Apart from that, of course, there is plenty of other, let's say, tools and solutions available to help you with scalability, such as thin clients for HMIs, or you could even replace, if you do material handling, some standard conveyors with some more smart, flexible conveyor systems. So there is plenty of other things, but I'm not going into detail here. So if I had to summarize our strategy that we can give to new companies or to new startups here, is really start creating a strong network and control specification. So that's the basics for everything. Standardize as much as possible so that you can really create those lean architectures. As I said, just use one single network if possible, from the OT layer up to the IT layer. That will save you a lot of pain once you digitize your operations further. And as I said, last but not least, in terms of the management software, try to make it modular so that you can also add more applications and more functions on top of it later. Or today, I think it's becoming more and more common that companies also use cloud-based software as a service solutions for the manufacturing environment. That also can give you a very high flexibility and can also help you to easily scale.
Thank you, Christian, for that answer. That how can we solve the challenges that gigafactories face while scaling up through automation. Uh, Coming to Mr. Colin, most of the new battery manufacturers they go for the turnkey solutions for battery manufacturing in terms of their equipment. Do you recommend the same, or do you choose that to see having multiple suppliers with a specific expertise or a standalone equipment?
It's a great question, and it's kind of a recent development in the industry to have access to a turnkey solution. But as Dr. Upreti pointed out in the beginning, part of our value proposition and our business model is to bring the supply chain to the table, fully qualified supply chain to the table to help stand up gigafactories. That includes machinery and equipment for C4V. So we actually talk with and run them through a 5-phase qualification process in order to get them on board and get them to be a screened and supplier to gigafactories for further evaluation. Once you can't simulate the scale that a gigafactory puts on a piece of machinery and equipment in the lab. So this is a fairly recent phenomenon that we've run across anyway, where one vendor tries to provide the entire process from mixing all the way to the end to shipping to the OEM. So we haven't run across this a lot in our travels, but it certainly has its pros and cons, and it's very attractive for people from a one point of contact situation. That's a key thing. It simplifies things. If you have an issue or a problem, or just to make the order or talk about how we're going to engineer the machinery and equipment layout on the floor and so on, it's one phone call. You don't have to go to 10 different vendors or 6 different vendors in order to get it done. So that's a huge advantage to a one vendor turnkey solution. We also see that the integration becomes part of the project. I mean, they are the one vendor bringing everything to the table, so integration kind of becomes part and parcel to the project, and it can be more efficient from a resource allocation standpoint. I mean, this is a huge capex expense. The biggest expense in standing up and setting up a gigafactory is the machinery and equipment purchase and the time that it takes to get it created and the downtime in the factory and so on have huge impact on profitability and so on in the short-term success of the project. But on the con side, there's not a ton of experience of companies that are doing this turnkey solution. So we haven't found any one company that actually provides a 100% solution in-house. So they don't make every part, mixing, drying, stamping, stacking. They don't do it all. They still have to subcontract, even though they don't advertise that. They call it a turnkey. Still one single point of contact. So there isn't a lot of experience out there with people doing it. And then also I don't know of any right now that actually provide 100% of the machinery and equipment across the line. And then the ultimate question is cost. What is the cost of that convenience of the one point of contact? And how does it impact if they still have to go out and sub to other machinery and equipment makers in order to fill in the little small pieces that they don't already do? So obviously cost is always a consideration, but I think it may be on the con side right now. My assumption is that there's no savings there, but there may be a little bit of a cost increase. It's just a matter of how people want to quantify the efficiency of one point of contact for ordering and engineering and follow-up and integration and so on. So it's an interesting concept. We hope that it continues and it simplifies things quite a bit, but I think the jury's still out on whether it's the best choice out there, and we'll see how it goes.
Thank you, Mr. Odin, for that differentiating between one supplier and having multiple suppliers. So next question is a joint discussion. So the question is, as the battery industry moves towards giga scale production, sustainability becomes an increasingly important factor. How do both Rockwell and C4V integrate sustainable practices in manufacturing process as well as to the industry as a whole? We can start with C4V.
Yeah, thanks, Vikram. So, of course, the way we look at the sustainability is starts from the chemistry itself, right? That is part of the product. Then you get into the process, so all your manufacturing processes, which includes automation and how efficient these processes are and the energy uses of these plants. And the third is how you are getting into the data side of the value chain. So traceability, getting into the ESG an impact factor of each of these components, how they contribute to the performance, not only the cost and let's say the battery power density, cycle life, which is performance, but also their greener and toxic footprint, right? So these are very important. So the three things, the way we explain is we call the chemistry the heart of the system, and the manufacturing whole equipment side is the muscle power, and that become your backbone, and the data becomes the brain. And then you have to sync these all throughout the value chain to make sure that you are able to produce a quality product, but also you are able to monitor the greener footprint of that product. Because if the batteries are produced in a toxic way, that defeats the purpose. The whole electrification is for the reason that we can create green technology, and if the batteries itself are toxic and polluting, then that is not really a long-term solution. So we have been looking into that. We have a dedicated supply chain team that gets into the traceability when we do phase one, phase two evaluations. We definitely work with vendors to evaluate what their footprints are, and then how it will look going forward once the Gigafactory produces that and getting into cell to pack making. And then on the chemistry side, we do have a very unique chemistry that basically eliminates cobalt and nickel from the cells, and that has its own impact. And I think having a product that eliminates some of these toxic and rare metals gives you strength to diversify your supply chain as well, right? Otherwise, you're dependent on a particular jurisdiction or country and a process. Then your hands are tied because you are downstream. You can't do much. You will buy what is available. Whereas if you can use metals that are available easily, I think you then have a choice to pick metals with not only cost impact but also the environmental impact. So that's the second one. And then I think the third, the data is very, very important. And while we call it from molecules to machines, where you need the chemistry to speak to your equipment, and other way around. I think going backward and forward in the value chain to make sure these components and product are able to speak to each other. I think if you build a sustainable robust product, you could avoid situations like fire hazard, and make batteries that you could even predict performance. So that from your PLCs to when you start getting the DNA part of the product component, and connecting those dots also become very important in the sustainability side of the product. So with that, I think I'll probably invite Christian to comment on this topic, because they are one of the world leaders in automation. And so Christian, over to you.
No, thank you, Shailesh. That's very interesting topics, and I would like to pick up some things that you brought up just. So overall, I would say at Rockwell Automation, for sure, sustainability is a priority, right? So we focus on all three pillars of ESG. So that's environment, social, and governance. So this is what we have to do. And I think if you want to be really serious about achieving net zero, I think you also have to, as a company, set yourselves ambitious targets and then really start making processes more transparent. Shailesh, you talked a lot about of data, right? And I have the same opinion. It's a very simple principle. What you cannot control what you don't measure, right? And digitalization is really here the key. Your data to enable or unlock energy saving opportunities. So this is really the most important thing here. If we take the environment out of this ESG here at Rockwell, we have, of course, as you can imagine, developed specific solutions again to tackle that topic. So we have solutions to manage energy, to manage water, and of course to manage waste. So at the end of the day, all those solutions enable you to collect data from disparate sources. And if I talk about sources, I'm of course not only talking about electricity here, I'm talking about everything that you need in your plant that starts with water, air, gas, steam, and other things, right? That might consume energy from your plant here. And this is then where you can really start to discover cost saving opportunities and potentials. Because eventually you want to be able to somehow manage your energy performance, then create or let's say use the data to do some meaningful analysis, and eventually you can also start then creating reports to get more insights. Where do I need to look? Where's my main drivers for energy consumptions, and of course also later for compliance requirements. Another thing, maybe example from Rockwell in terms of waste reduction, we have since many years implemented a global repair and remanufacturing service. Not sure if you're aware of that one, but the good thing about that is customers and manufacturers can just bring their faulty or broken automation and electrical equipment to us, and we repair it for them and bring it back to its original operating condition. And now the great thing about all of this is that it's available and open for all brands, not just Rockwell Automation. So even if you bring any other electrical equipment to us, we are very confident that we can fix it. So that's one thing. Specifically, Shailesh, for the battery industry, of course, you did not mention the term specifically, but you talked about supply chain traceability, not just traceability on the shop floor. And this is also something where Rockwell Automation, I think, can contribute or enable manufacturers to participate in a so-called digital battery passport. So I guess you have heard the term before, but maybe for people that are not so familiar with what a digital battery passport is. So it's basically a solution, an electronic exchange system, right, cloud-based, that enables you to track and trace all your battery materials across the entire supply chain, right? So it's a digital representation of your battery cell that contains all the information about different things from the supply chain. And that really goes right from the beginning, from the mine to cell assembly to cell integration into the various applications, and then further on to recycling. In my region, in the European Union, by the way, this is already becoming a requirement with a EU directive that regulates things like how much CO2 emissions are created throughout the process. The absence of child labor, of course, you said, there is certain materials you will want to get rid of in battery cells. And then, of course, it's also going to become a requirement in the EU how much recycled content you use in your battery cells. So this is also going to be one thing to create the circular economy. And yeah, those are just a few examples. Of course, be ensured that everything that I just talked about here, we also use it in our own manufacturing plants. So Rockwell is also a manufacturer. We make our own products. And of course, we have set ourselves pretty ambitious targets in achieving net zero things. And yeah, we take this also very seriously here.
Thank you, Christian. Since this topic is turned towards sustainability, what are the recycling goals at C4V? And Christian, let us know what is the role of automation in battery recycling as well. Yeah, Shailesh, I think you can start with what are your recycling goals.
Yeah, absolutely. I think recycling is very important piece of the value chain. Whether you see it from upstream or downstream, I think it fits in a very nice way for the circular economy. And for us to develop processes that are greener, cleaner, there are, as you start getting into low cost components, for example, LFP chemistry, where there might not be incentive to disintegrate the chemistry, and the metal cost may be lower side. The innovation needed. There are companies who are developing direct recycling processes to recover the LFP, from LFP to LFP, and so there is a lot of innovation going on, and we see recycling as very important aspect as gigafactories get scaled. During the scaling process, as you go from lab to giga scale, a lot of scrap generated in that process. Plus, as you run the plant in 3-shift operation, even with full automation, because of the complexity of the ingredients and the components, I think you do end up with a lot of scrap, whether it's throughout the process or end of line, producing a cell that will not meet your spec. So that should go into the right home, right technology, so you could proudly, clean your whole value chain offering, right? Because the product, when you sell, your byproduct or your waste product become integral part of your ESG component, right? So you have to have that well taken care of. And I think at C4V we have been working with at least 7 to 8 different recycling companies. So we evaluate technologies that will best fit our chemistry and our gigafactories to make sure that end of the day, and then also, jurisdiction, like, because you have factories coming up in emerging markets, you want to have access to local recyclers. It's very challenging for overseas company to set up recycling infrastructure every place. So we look into the diversification of their presence, but also diversification of their processes, and how they are able to recover component in a very cost effective and cleaner way. I hope that gives you at least some high level overview of how we look at um, recycling, and how we have been building that piece of the value chain very, very strongly.
Yeah, that's a very interesting perspective, Shailesh. So I think without a doubt, better recycling is key for sustainability, right? And also to create a circular economy in the industry. So I think that's more or less clear. I also think that as in every other industry, automation again plays a key role also here. But in order to explain a little bit more our role here, maybe I have to break this process a little bit down into the various steps, and then highlight maybe just a few areas where I see some, let's say, potential for improvement. Let's call it like this. So if I look at the recycling process, I see two major steps. So the first one is the recycler receives the packs, and then they do a disassembly process to basically disassemble the pack from pack to module, right? And those modules are then just crushed into smaller particles, and then which they call black mass, which end up in some kind of big bag. Sorry. The second step is then the hydrometallurgical processing, right, where you then via some chemical treatment extract all the materials so that it can be reused in the battery cell manufacturing process. So if I look at this, I mean, overall, I would say the entire recycling process today is pretty well established. There is a number of different players on the market, and of course, the degree of automation is also very high. So I think that's all good, but there is still some weaker areas, and in particular, at the very first step that I mentioned before, this disassembly process from pack into module. I think this is an area where automation can do a little bit more to improve the processes here. If we look at the current quantities, okay, that might be acceptable. If you look at the disassembly process, it's still to a high degree manual labor involved, right? It's pretty complex to identify where are the unscrewing points, how do I remove the cover, etc. Doing that by robots is pretty complex. And again, if you look at the current quantities on the market, that's all okay. It might be economical, but eventually, if we look further to the future, there will be a huge volume of batteries, right? And there will be also huge volumes of batteries that need to be recycled. So I think this is where automation companies can come into play a little bit more and try to introduce more advanced solutions. I'm thinking about vision systems. I'm thinking about LiDAR scanners. I'm thinking about cobots, and of course there will be still people around. So you will also have to make sure that that your systems and your automation can interact with each other, taking safety zones into account and things like this. And then another thing I believe that would be of tremendous value for recyclers and for all companies in general is again the digital battery passport. For a recycler, if they knew in advance what materials are included in the pack, if they knew in advance what is the status and health of each cell in the pack and in the modules, I think that would speed up and make the process much more efficient. Because at the end of the day, you don't need to crush all cells, you don't need to recycle everything. Recycling could also mean that you just have a look, if you know in advance, okay, those are the good cells, those are the bad cells, and the good cells you could reuse for a second or third life in a different application, maybe not a demanding automotive application, but still, right? So because the digital battery passport, it includes the full history of the battery, and I think there is a lot of value here. So
Yeah,
that's just a
great.
few thoughts. I think there is a lot of good things that you can do, and for sure there is more to discover.
Yeah, absolutely. I think very good points, Christian.
I have read it somewhere that recycled materials are much more better than the virgin materials, which goes first time into the cell. So, yeah, can you share some insights on that?
Yeah, I can comment because we are also doing a project, DOE USABC project with GM and Ford and Stellantis and C4V involved, American Battery Technology involved. We looking into how different let's say components, primarily the cathode, which is the major cost component, how a recycled versus virgin and a combination, right? So in ratios 25 to 70%. And the study shows actually, I wouldn't say they perform better. Maybe there is a, because you're not dealing with indefinite impurities, because once these metals are used in a cell, what metal impurities inside the cells are versus when it comes out of the ground in nature, right? So I would say the processes may be more efficient, and your ability to kind of tailor your processes and energy need and ESG footprint, your ability there is improved. But I think material is material, and mostly they go by spec. In fact, it will probably be a problem for manufacturing plant if you have a better and not better, because in manufacturing consistency is important now, not good or bad. It's just 5% better may not be an ideal scenario of that particular day when you're using a recycled material on production floor, because you need to have a very consistent throughput. So, and that's where the quality specifications of each component are important. So if it is better, you have to somehow reduce it to the same spec that you have a virgin material eventually. So I think with that, we do see that the recycled material, you're able to do it more effectively, and I think it makes its way to sell much faster than a virgin, from cost and efficiency and footprint perspective. Maybe Christian, if you have your thoughts on this, I'll hand it over to you.
No, I think you explained it very well. So my knowledge also more comes from public research documentation that is available, but of course I cannot confirm whether the recycled content is better, or the minimum that I would expect is that it matches the similar specification as the newly refined materials, of course.
Great.
Thank you very much for sharing your insights on your sustainable practices. With this, we have come to the end of this webinar. So before ending, do you have anything to share with our audience?
Now, thanks, Vikram, for inviting us to the battery line webinar. I think it was very interesting from Rockwell side, understanding how they are looking at the value chain. So it was very insightful webinar. Thanks for inviting us again.
Thank you. So
Also from my side, thank you very much. It was a great discussion, good conversation, and also thank you for sharing the insights as a battery cell manufacturer. It was very interesting also to maybe reconfirm some things from our end. So thank you very much for that.
A pleasure, gentlemen. Thanks for the interesting conversation.
we thank our experts from C4V and Rockwell Automation who actively participated in this webinar to share insights on scaling up the battery production and the role of automation while scaling up. Thank you to our audience for joining the webinar. So if you have any questions or would like to talk more with our experts and partners, please send us an email at info@batteryline.com. And thank you once again for joining this webinar and have a great day.
Thank you.
Bye,
Thank
everyone.
you. Bye-bye.
Bye.